Hey guys, so we're going to start working on our third standard about force and motion. So our first part of the standard is about speed and velocity and acceleration. So if we have this graph and it's distance versus time, I want you to kind of create a story about what is going to happen as we go through. So I'll give you some time to think about what's going to happen as we go through. So what's going to happen in time point 1. So our distance, first we're at 0, and then as we go through, we're going 10, 20, and 30. So at this point, we are moving at a constant speed. Then at point 2, our distance is the same, 30 kilometers, 30 kilometers, 30 kilometers. So that means we are staying in the same place. So at 2, we're stopped. And then at 3, now we are going, and the line is steeper. We're moving again. So at this point, at 3, we're going faster. So you might be running at this point because it's a faster, steeper slope. And then at point 4, we're at 60 kilometers away, and then we get to 40 kilometers away, 20 kilometers away, 0 kilometers away. So we have turned around, and they're going backwards. And you notice that 4 is going to be happening faster than we did at 1. So we're walking, stopping, running, and then we turn around and ran back. And that's kind of what's happening in this graph. In order for acceleration to change, in order to accelerate, or that means we must have velocity changing. And in order for acceleration to remain the same, our velocity must stay the same. So as a reminder, there's 2 ways we can change something's velocity. Those are, we can change its speed, how fast it's going, or we can change its direction. Because remember, velocity is speed plus direction. So if we change either of these things, we are changing the velocity. So if I change either the speed or direction, I will therefore change the acceleration. So we're going to go through some examples, and we're going to figure out what's happening to the acceleration in each example. So number 1, a car goes from 10 meters per second to 5 meters per second. So in this case, acceleration is going down. We have a negative acceleration. It's slowing down. Number 2, a car goes from 20 meters per second and it stays at 20 meters per second. In this case, it's doing nothing. We are not accelerating. Acceleration is 0. We're not speeding up. We're not slowing down. We're staying the same speed. Number 3, a car goes at a constant velocity. Same thing. Again, nothing. This is the same way of saying what's happening in number 2. Constant velocity. Constant is not changing. So the speed, the velocity is not changing. So therefore, it's not accelerating. Number 4, a car speeds up. And this one, our acceleration is going up. We are getting faster. Number 5, a car turns a corner. In this case, our acceleration is changing because we are turning a corner. We are changing the direction. Number 6, a car turns a corner while moving a constant velocity. So they're not slowing down to turn the corner. They're just turning the corner at the same speed. This is still going to change our acceleration because velocity is not just speed, it's speed plus direction. So that means our direction's changing, so our velocity is changing, so that means we're accelerating. Okay, so now we have a similar looking graph, but notice now, instead of distance, this says speed over here. So now we're going to create a story for what's happening in this graph if we have speed versus time. So at this beginning part of our graph, our speed is at 0 meters per second, 5 meters per second, 10 meters per second, 15 meters per second. So we are accelerating, we are speeding up. We were stopped, and now we have sped up. Then at 2, we're at 15 meters per second, 15 meters per second, 15 meters per second. We still are moving, but now we are not getting any faster. We are at the same constant speed. We are moving at a constant speed. Then at section 3, we're going 20 meters per second and then 25 meters per second. So now we're speeding up again. But notice that we were speeding up faster in 1 than we were in 3. So we were speeding up, then we're at a constant speed, speeding up even more. And then at 4, now our slope is negative, but this doesn't mean that we've turned around like it does when it's distance. This means we're getting slower. 25 meters per second, 20 meters per second, 15 meters per second, 10 meters per second, 5 meters per second, 0 meters per second. So this means we are slowing down so much that we finally stop at the end. So here we're stopped. We get faster and faster and faster and faster and faster. Now we're like maybe jogging. We get faster and faster and faster and faster, and then we start slowing down and then we stop. So this is the story of what's happening in this graph. Okay, and that is the end for this first standard.